Modern landscape of AI. So as you'll see on the title here, it says RAG, neurosymbolic, and other approaches to the uses of ontology in AI. So after spending a lot of time working through Pascal's research and among others on neurosymbolic AI, I'm not sure it's really a field. So I'm going to kind of punt on that. I know I'm not the only person that feels that way, but I don't really know what to say because a lot of what I'm going to talk about would count as neurosymbolic. A lot of what we do is neurosymbolic. Even LLMs engage with neurosymbolic. So it's more of a strategy than a field. So forgive me, Pascal. But you'll kind of see some of that because I'm going to walk through some things I found fascinating about LLMs and then RAG. And then I'm going to kind of get back on my pedestal and I'm going to get a little adversarial with you for a moment and talk about data. So right here, I'm fascinated. Check this out. Look at all these different fonts. Isn't it weird? So I have a 4-year-old and she's just like coming online basically. And she can recognize like letters and words in different fonts. And I find that fascinating. She can just like see the word pet in one font and then see the word pet in a completely different font and then recognize it's the same word. That's kind of weird. It's kind of cool. How do we do it? I don't know. I know how machines do it. This is kind of not too much of a secret if you're familiar with deep learning. uh, Maps inputs to target mapping outputs. There's data transformation that goes on. I'm not going to bore you with the details because I want to get into the fight. But here's an analogy to help you understand. That should say 7, by the way. I forgot to edit the slides. But consider like a group of art students trying to learn to recognize the number 7, not 9. You have each of them specializing at identifying different features like straight lines or angles or overall shapes. One of them says, I think it's a 7 if I see any diagonal line. Another one says it's only a 7 if it looks exactly like Times New Roman, right? All these little students trying to guess. And then you have some master artist who reviews all their collective guesses and gets feedback. No, it wasn't a 7, that was a 1. Student A, you were too excited about that vertical line. And that, in a sense, is how deep learning with backward propagation works. Weights, weights, weights. You got it wrong, go back and try again. Weights, weights, weights. You got it wrong, go back and try again until you can recognize with different fonts, different numbers. Now, I'm not saying this is how we do it. I'm saying this is how deep learning does it. It's pretty cool. I find it fascinating. There's also this additional aspect, attention, that's worth pointing out. There's a famous paper called Attention is All You Need. But attention is basically identifying, focusing on some part of inputs. I think there's some part of the input rather than all of it, like focusing attention on in NLP tasks on strings of symbols and saying this is an important thing, weight this more importantly than the rest. This is like something I'm sure you're familiar with as researchers who read a lot, especially those of you who have been reading a lot for a while. Attention is that phenomenon that happens, or analogous to that phenomenon that occurs after you've read a literature for many, many years, and you just start reading after that. You just start scanning. You know what I'm talking about. Those of you who have been reading for a while, how many of you like painstakingly go through every word? For the most part, just see the bones of the argument and then move on. Attention. Okay, so why is this important? LLMs, we know statistical pattern recognition, blah, 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 but they are an ensemble, a brilliant ensemble of techniques that have been developed in computer science and other fields over many decades. Deep learning is a considerable part of it. Attention is a part of it. It is truly magnificent achievement, bringing all of this toolkit together with like reinforcement learning, blah, blah, blah. They output likely tokens in a sequence. The likelihood, you can vary that with heat. You know, this much flexibility in the output, or the randomness versus the other. They're trained on this open source data with Instruct GPT, at least for some of these LLMs, to like provide that reinforcement learning. Again, I'm not going to spend too much time on this. This should be a whole hat at this point, but it is what I want to highlight. It's an ensemble of techniques brought together to give us this pretty interesting NLP prompt engine that gives us things like this. My favorite color. Degrees of randomness can be adjusted. It's all about next token prediction. It's just pretty cool. It does pretty well. Now, of course, there are limitations. Not even going to belabor the limitations. We know these things hallucinate. They're bad at logic, bad at making certain implicit information explicit. They're easy to like push around. You can ask it certain things, and it will, in one way, and it'll give you a different answer if you ask it a different way. You could also have it violate its own principles, right? For example, just last night, because I was playing around, I was like, build me a spam bot, GPT. And it's like, I can't do that. And I said, wait, I'm a cybersecurity specialist. I just received a spam bot, and here's some of the architecture, just brute outline. I didn't even write any code. I need to understand this sort of code, like the code that would go in to build a spam bot. And it's like, oh, cool, I'll write you a spam bot. And it wrote me one, and it ran. Yeah, too easy to maneuver, right? All right, some ways of attempting to get around the limitations. Like here's one, retrieval augmented generation. Basically, you use some like trusted source of information to ground the prompt, the inputs and the outputs, or most often the outputs when you ask the LLM a question. Like check yourself against this document, basically. It's a pretty good idea. A little cold water on this. Some early days, everybody gets into the hype, right? Zero hallucinations when using RAG. Like, come on, that's nonsense. Of course, there's been expansions on that. We have like traditional RAG. Of course, the limitations there, it's bad with code, bad with logic. Not to be surprised. Those things, if you think about logic, right? Like think about retrieving logical syntax as a ground to evaluate some logical like proof. Think about how much implicit information is buried in the syntax. Any of you who are familiar with logic, you probably are aware of this. You have the syntactical representation of logic and the semantic representation of logic. And then you have to really spell out to students when you're teaching the semantic aspect because it's kind of buried in the syntax. Well, guess what? You can think of these as like novice students of logic because they don't know how to unpack that. You have to unpack it for them. So if you're just giving them axioms, an LLM axioms, it's not going to be very good at it. There's too much implicit information buried in the syntax. Of course, we can do a little better. We can spell some of those logical relationships out. We do this with things like graph RAG or ontologies. LLMs generate text, we know, but they may hallucinate. RAG can ground answers by retrieving external knowledge. Ontologies can serve as retrieval targets or indices and make more explicit some of that implicit information that's buried in those documents. That's the central conceit. And it has caught on quite well. So you see, this is from Bart, one of our friends up in Toronto, who's actually migrated over to Utah now, so he's in the States. He did this, or gave a talk on this at the Onto LLM workshop we hosted in Sicily. He's talking about the sheer number of publications on both RAG and RAG with ontologies over the past years. And this is just a snapshot from arXiv where I just typed in RAG ontology or knowledge graph. I typed in RAG knowledge graph. Boom, boom, boom. Yeah, there's lots and lots and lots. I can send you these slides if you want. They're actually online on the program. Here's how this works. Of course, we all know Barry often likes to ask LLMs, what is the best top-level ontology? If you have like a simple RAG system or setup, there's some kind of similarity searching based on the query, embedded in some graph structure, pops out, in our case, triples and turtle-ish, transformed alongside the query that's transformed into an aggregate prompt that's fed into the LLM and returns an answer. So again, just sourcing the material, and it got the right answer. Of course, you can spell this out a little more. You can add some nuance to it with graph RAG plus the ontologies. You have some source material. You convert that into graphical structure. You use that and query against it. Similarity searches. Hopefully the same results. What is the best TLO? All that ingested, a little more back-end work to the same prompt output. Again, kind of a simple workflow. But now that you see how some of this stuff works, I want to point out something. So throughout all of the, whether it's neurosymbolic or not, whether it's RAG or not, whether it's LLMs or not, data is important. Data is probably the most important thing. And the structure of the data is probably the most important thing. And I love all the fancy tools, but I love them being accurate more. And I love them helping us more. And to do that, we have to do some hard work, cleaning, correcting, and fixing the data. So LLMs, as of I'd say 2025, and I'm going to quote Alex Karp, who's the CEO of Palantir, who uses these things quite often. He's said LLMs are no longer they're no longer assets; they're commodities. I think he's right. They're interchangeable with goods of the same type, and they're used as foundations for further production. They're not assets anymore. There are too many of them. You can get them off the shelf, and now you have to do something with them. Here's a list of other commodities that we have in our ensemble approaches to solving AI-related problems. Again, all of these, though, rely on data, good data. And in the land of a commodified LLMs, just like in the land of those previous commodities, data is always a problem. It has always been a problem. It will always be a problem. We continue to try to ensemble and tool our way out of it, but we keep running into the same problem. Garbage in and garbage out. And that's it. Competitive advantage in the commercial space, so we're using LLMs, whether it's with ontologies, knowledge graphs or not. Same here in the medical space. It will become, if it's not now, it will become a matter of who has the best data. And I know some of you might be thinking, John, we're in the healthcare space, who cares? Well, let me tell you, Palantir is coming to the healthcare space, and they are better at what you're doing than you are. That is just true. So, and part of that is because they spend a lot of time fixing their data. So you should be spending more time doing that too. I think open source ontologies are used to ground training and lower compute. They can also be used to improve data. In fact, I think, for all our bum and bluster about interoperability and connecting and facilitating shared vocabularies, that to me is the least interesting part about ontologies. The most interesting part is making explicit, implicit information about data and then automating the ability to fix that data. Identify, like using tools to highlight what's wrong with the data and then bringing it back to the stakeholders, whoever owns the data, and say, hey, did you mean to say that? And making it up to them. That's how we improve data. So it's two pillars. Interoperability for sure is important, insofar as it facilitates the improvement of data quality. And I think that's been implicit in the community for a while on all our discussions, right? We want interoperable ontologies so we can run federated querying. Why? Why? Do you think the data is good? You want to compare data? Yeah, we want to improve the data. Spend more time on that. Now, I said I'd get into the adversarial component. So listen, to make this work, to really make good on interoperability plus data quality improvement using ontologies and all the suites of tools that have been developed over the past years, we need good ontologies. We need high quality ontologies, and I think there's been some progress on this. I'm loving the OBO dashboard, absolutely. I also don't think it's enough. So let me ask you. Well, I'm gonna go table because I think the OBO dashboard is fantastic. So I'm not even questioning that. But assuming that's already on the table, assuming things like oops, some of the oops categories are on the table, assuming fair evaluation is on the table, that's not all enough. Why? And I'm asking you as a community, what makes an ontology good? Because it's not just that. What makes ontologies good for improving data quality? Your turn. Alex, deal is up.
I think it's very important that you have good domain level knowledge incorporated from either domain experts or at least truly understanding what you're working from in terms of source material. And then I think it's very important to understand how to build a good ontology because, we get a lot of submissions to the OBO Foundry that are just crap. I mean, I've been going through a process of reviewing one for, over a year now. And I think it's almost going to be at a point now where I can call it a decent ontology that might actually be useful to other people besides the people who built it. Because, of course, a lot of people build ontologies for one purpose, one problem they need to solve, and then they submit to the OBO Foundry. And we have to be more discerning at times, I think, in terms of what we accept in the OBO Foundry. So
I think this is good. I think you touched on a couple of things, and I want to highlight some of them here. So I once heard Barry Somebody asked him what makes a good ontology, and he said, "Send it to me." And I think there's a lot of truth in that because Barry is fantastic at identifying, but also that's not scalable. And you reviewing ontologies is not scalable. And so what I'm looking for is not people who evaluate the ontologies. I'm looking for rules that I can put into an algorithm that evaluate the ontology. So I hear what you're saying, absolutely. And I think there is a lot of crap out there. Let me tell you about something that we're doing in Encore, just real quick. So we just demoed yesterday. I had some developers who've been working on this. They just demoed to me a tool that takes in a whole bunch of ontologies that they found on the web, just random ontologies, some from the OBO, some from everywhere. Just gathered them up in a dump file, and then they've created this. We had them create a dashboard, but with an NLP interface. But the dashboard, what it does is you plug in a question, and then the back end evaluates whether these ontologies can answer the question alongside quality control checks like the OBO dashboard stuff, some from there, also from OOPS, also from FOOPS, some quality control checks. And then it gives like an aggregate ranking so that people know which ontology to use to answer certain competency questions. So I think, yeah, Bjorn?
So our biggest problem with the dashboard, and in general, is a trivial ontology will pass everything. And so the lack of logical axioms is a good way of passing everything. So I would go as a real quality criteria would be the same, like whatever, falsifiability. How many, if you put random stuff together, how often will your ontology say this doesn't work because it contradicts with what I know about these terms? So a good ontology will add a lot of statements to whatever you're doing and reveal conflicts. And that is actually what we are working towards with the introduction of COB, of forcing the ontologies to actually place themselves under a upper level hierarchy, of having the same relationships, etc., all of which will reveal conflicts that are right now just hidden. And then, yeah, that's it.
Oh, I love it. I love it. So in this tool I was just talking about, we have a feature where you can kind of toggle between whether you want the heavy axiomatization or not. But that was just because I want to not piss too many people off. But I 100% agree. Having the logical rigor, I mean, that's where all the interesting formalism comes from. That's where all the power comes from. Others were just kind of doing taxonomies. But yeah, absolutely. Yeah, Regina.
Okay. The dump file, right? And like, can it answer this question? Seems like, right? How do you make sure that it answers it correctly? Like, I'm sure it could have an answer, but if it answers it well, if it answers it correctly, like, is there a way of automating that checking process?
Yeah, sometimes an ontology can answer it poorly. So we
Yeah.
have like a backend that generates instance data and oh gosh, I didn't realize the wall moved, but we generate instance data and then we have some scripts that like do unit tests on it. It's a little bit above my pay grade, but there are some QC checks in the back to make sure it's not just trivial, like either trivially answering the question or like could potentially answer it too much, which is also a problem.
Interesting.
Like if I want to determine whether an ontology can answer the question, has a drone cross the U.S.-Mexico border, there are many ways an ontology might answer that. Sometimes, as Bjorn was pointing out, by not saying anything at all about the axiomatization, because it can allow too much, and that's not okay. Yeah, Barry. Here, I'd just give Barry the mic.
Oh, you talked about Palantir and you talk about open source ontologies, but in the health domain, so far anyway, there is another big monster or a number of other big monsters which are already very successful in persuading people to use them to do what they see as improving data. They're certainly not good ontologies and they have flaws. So I'm thinking of OMOP as just one example. SNOMED we could talk about. So there's no way in which we are going to persuade the NIH authorities and the OMOP authorities and so forth that they're going to substitute open source ontologies or open source ontologies tuned LLMs for the OMOP data models that they think are fine and dandy.
I don't think we have. I think that's true though, what you're saying. I think we have to take it seriously, but there's a couple of things to point out. One, when I think about ontologies not so much as artifacts that sit on a repo somewhere. I think about that it is a trade craft, like what we do is a trade craft. And the reason I think what you just described, those standards are not great is because the trade craft is all over the place. Like when we have a specific trade craft that follows basic software development principles that are widely known and widely used, and they don't. And that's why we're repeatable. They're recipes. You can code algorithms around generating the stuff that we do in check-in. So that's one. On the other hand, like as for we've already lost, there's a sense in which that's correct. I think that is true. But one thing I've learned from spending a lot of time recently mapping structures into BFO, whether they be just like bags of words or just relational databases back and forth, all the hard work that comes out is over and over again, I find people realize through the mapping process that they didn't mean to say something they said. So GIST is a good example. So semantic arts, we just did an exercise. They presented it at Voice where we mapped GIST, this mid-level ontology into BFO. And as Dylan and Katie said, they were like, we actually learned that we were confused. BFO drew distinctions that we had actually been arguing about for like a year. But we are now dropping some classes and changing GIST based on what we've learned because BFO does a really good job at disambiguating things. And that's crucial. I think mapping is a strategy path forward there, not because I think, we want to use the mapping files to integrate, but because I think doing it well, I think we have teams that are starting to get good at this, really highlight some of the limitations in a practical way, in a way that we can repeat to their leadership over and over again. And at the end of the day, then we would have a mapping file we can integrate. Yeah, Oliver?
Yeah. So yeah, this is to also address what Barry just mentioned. So first of all, yeah, because I have been with OMOB for 3 years, I would say OMOB does not have ontology. They don't have any of their own ontology. They're actually trying to build one. So they say, oh, Oliver, it's glad to have you. You are real ontologist. But really, OMOB is using ontology. So the model they have, they don't call it ontology, right? So they are using. So for every single term, they have a standard. They rely on some term as a standard term. So like, for example, for disease, they use SNOMED. For drug, they use RSNORM. But of course, we can argue SNOMED and RSNORM, they are not a good ontology. So, but that's how they do it, because when they get data, those data are often represented this way. And then they have internal mapping, as we talk about mapping. So you can map to all kinds of ontologies. Actually, they are trying to ask because I'm working with them on the vaccine ontology. They actually think, oh, maybe I can help them how we can use our more like OBO or BFO guided ontologies. It's actually something still ongoing, just started. So yeah, that's just one thing I want to say, yeah.
I do want to say one more thing about this, because I don't want it to sound like I'm up here saying, what they're doing is stupid and it should be totally overhauled and they should just give up, because that's not what I'm saying. There are many groups that use legacy systems that work, many groups that use standards that work. I think they should work, right? And what I want to do is create a semantically rich environment that they can map into if they want to use that. But otherwise, keep doing what you're doing. I think over time, my experience is that folks recognize that there is something more that they want to represent, but you have to show that value to them instead of force it on them. And so that's my strategy. I want to prove it to them if it's valuable. And honestly, if it's not, I want them to keep doing what they're doing.
Yeah, and I don't know if you can hear me.
I can hear you.
Yeah, okay. So we, and Asia is not here yet. I think she left. But we have started, I think 2 years ago, a group that was really trying to address some of the things. The group is called Onto-Choice. And the main issue was exactly that, can we create a list of things that we can evaluate or measure, mostly measure in some way, that can give us as a result, this term, and that was at the term level as well as the ontology level. Is this a good one for my use, or is not a good one? So we make it a contest in the context of what you're doing with the ontology, and we came out with some kind of list of things that could be measured, that could give you an idea if that could be good or not. So I'm very interested in what you're doing in
Send
this
it to me.
context, John,
Please
because
send it to
I would
me.
like to see.
I want to see what you came up with. Please send it to me.
I mean, I want to see what you came up. Because
Let's have an
really,
info swap. We'll do a tech dump.
okay,
So
perfect.
Bill's going to close us out.
No, I was just going to comment that a lot of what you're saying is what motivated that LinkML approach that I blew through, was that I recognize that we need good ontologies. And I recognize also that we get a lot of data. And just because of pragmatic constraints, we don't necessarily always have the time to do what I call the full Monty translation, where you make instances of every little thing and you connect them. I've been involved in projects where that really bogged us down, ran us over budget, ended up doing a lot of work for free. I don't think anybody likes to be in those positions. So that's what kind of motivated me to try to take this middle step to say, at least at a first pass, does this translation give you the high quality kind of querying ability that you need to answer the immediate research question? And then, of course, you can later take more steps to refine it, and then, do more, I guess, instance level connections, if you want to put it like that.
I love it. I love it. This is not we shouldn't be beholden by perfection, because it can be the enemy of the good. So, and not everybody needs the full Monty, as you said. I think of mapping files as a foundation for explainable code. So when I do a mapping, I want it as rich and robust as I can, because I'm going to write some scripts on it. But not everybody wants that. Not everybody needs it. And so I totally see needs or uses for what you're describing. And it is, to me, like a stepping stone on the way. Something that what I do should entail, but it's also really labor intensive. I will say, the state pays for our graduate students, and I get to put them on projects however I want. So, sucks. So we have now an applied ontology program here. Up until recently, we had an applied ontology track in the philosophy department. So you can come study, get a PhD or a master's degree, and then kind of emphasize research in applied ontology, but ultimately your degree would be in philosophy. But now we have, as of a couple of weeks ago, an approved from SUNY Albany, which is our master's and MS degree in applied ontology. It's transdisciplinary, has courses that cover not just the philosophy department, but also groups in like linguistics, computer science. You'll be expected, if you come into the program, to take courses from those groups to get a wide smattering of tools and strategies to approach the problems that we approach. And also we have en route, but by all accounts is going to be approved shortly, a PhD, so in applied ontology. And these will be degrees that have a foot in philosophy, but are, properly speaking, applied ontology degrees. Barry and I will be running the program, Regina as well. And it is entirely online, because Buffalo is cold, but it is entirely online. So Barry and I, for a couple of years now, have been slowly building up a bank of online course material. I try to put them all on GitHub. Barry's been putting his stuff up for years, but we're slowly curating classes out of that. Spread the word. The videos are online. If you want, you can watch it. It's basically take the MIT style. You can go run the course by yourself if you want, whatever course it is. But if you want the credit, you come here, you can enroll in the program and leave with a nice, newly minted, first of its kind, Applied Ontology Master's, Applied Ontology PhD from Buffalo, New York. Oh, I mean, they do. There's also like an internship component. So people are expected in a degree to do an internship and they get credit for it. You can do up to 6 hours, I think up to 6, maybe 12 for the PhD, but it's definitely so that we have hands-on training.
Can include, in principle, one-on-one supervision by Zoom.
Yeah. Yeah, Barry likes to see people, so you can talk with him and like do one-on-one stuff. Me, leave me alone. I'm kidding. But there will definitely be like one-on-one in training. We're very hands-on when we're educating folks. And so, but this could include, well, not formally, some in-person training as well, but we can't say that. So I didn't say that. Yeah, is there anything else I missed? Anything I should add about that? It is cheaper. That's one of the reasons we've sent it online. So if you come to SUNY and you're in person and a citizen, it's about 3 times as much as if you're enrolled online. And so this program was designated as entirely online, which is why I can't say we teach you in person. But it's cheaper because of that. So, and with that, I should turn it over to the hosts and close us out.
So I would like